Okay, so what I wanted to start with is just let's go over the kind of stuff that we were kind of thinking about last time with our paper airplane slash Lego slash whatever kind of instructions. Um, and we kind of wanted to think of sort of what types of instructions did we have in the Lego, or not the Lego, but in the paper airplane stuff. We definitely had a lot of imperative or declarative kind of expressions where it's like, do this, do this, do this. Okay. In computer programming, that'll be a lot of let this variable have this value, or uh, do this procedure, or something along those lines. We didn't, in the paper airplane case, have any conditional expressions where you had to make an if-then kind of decision. Um, but we theoretically could have. So, for example, I mean, this one's kind of contrived, but a number of you guys tore paper out of a spiral bound notebook, and you could have something like, if you tear paper out of a spiral bound notebook, remove the frillies before you proceed. Otherwise, well, there were no frillies, so just keep going, right? I mean, again, that one's kind of contrived, but it works. Repetitive expressions, so or sometimes we could call these iterative expressions. Um, in y'all's case, I think with the paper airplane, you never repeated anything more than a second time. But theoretically, of course, you could repeat as many times as you could want. Um, or you could do something that repeats uh, not necessarily a specific pre-planned number of times. So say, for example, the computer program or the program is make peanut butter and jelly sandwiches. Okay. And I just keep bringing in loaf after loaf and bucket after bucket of peanut butter and jelly. Uh, then do you like know in advance how many sandwiches you're going to end up making? No, right? So even though you're just going to keep making sandwiches until you run out of material. Yeah.
And the rate, is that repetitive phrase in Python would be if out of ingredients break.
Uh, you could do that, or you could do a while loop, which is what how we'll write it, which is while you are not out of ingredients, then continue. Yeah. Um, right. Okay. So we'll look at the sort of different types of iterative expressions. There's two of them in Python. There's sort of three categories more generally. Python doesn't have one of them. Um, and then we'll also look at functions, which uh, in some ways work like functions from math class, where, what does a function mean when you're in calculus? You stick in a number, some other number comes out, right? Um, and conceivably, you could stick in like three numbers and a single number comes out, right? If it's a multivariable function. Um, as you kind of move up the chain mathematically, you can stick in basically any type of mathematical object and get out any other type of mathematical object. Um, the definition of function um, in computing is slightly more general than that. Um, but one of the other things that we can do, and we can do this in mathematics also, but you tend um, well, you can do this in mathematics, is where you have a function that is defined in terms of itself. Okay, so it's sort of got a self-referential property. That's called recursion when you do that, and it's a lot of fun, but also a headache. So anyway, okay, so that was kind of the broad strokes of the different types of expressions that we wanted to look at, and let me let me go and let me close a bunch of this stuff. This is from my other class. And let me, actually, you know what I need to do is I need to make a new folder. Yeah, Okay, I'll do this. I'll make a folder for you guys. Okay, and in this, I'm going to make a file which we'll call, let's see, okay, and I'm going to do this in Python. What I'm going to type for right now, let's sort of think about it that, like, yes, everything I'm going to be writing is valid Python, but don't worry about the fact that it's actually Python. Okay, the one of the reasons that I like to use Python for this with you guys is because um, it reads kind of like plain English, right? You could look at Python code and be like, oh yeah, I can see what this does without even knowing that it's Python. Okay, um, okay. So we've got declarative expressions. Oh, and let me go ahead and open up the terminal. Where's the button for that? There we go. Okay, it's bitching about PowerShell. I don't care. We'll use the bash terminal. Okay. Huh? What? Oh, yeah, that was from yesterday in my other class. They were doing loops, but in assembly instead of. Uh, okay, so we got that. All right. So the first category that we had, which was declarative expressions. So it'd be so in Python, anything that I put with a hashtag is considered a comment, meaning it's not code. It's just stuff that we could write either to ourselves or to somebody who's reading the code to kind of help them understand what's going on. Um, Different programming languages have different symbols for how you make a comment. In C++ or C, it's a double slash or a slash star, and then you have a star slash at the end. So again, just each language has its own uh, notation for that. Um, and so what we could do here would be something simple like, let's see, I could do, yeah, everybody's first program is always this, right? Hello world. Okay. So then to run this, I just tell Python to run it, and there we go. Okay, so this would be an instance of a declarative expression because I told it do something. In this case, it was print a string of text. It didn't have to be anything like that. I could have said x equals 5, um, y equals 7, print x plus y, something like that. Okay, so sort of mathematical type expressions, and not surprisingly, it prints 12, no big deal. Okay, so yeah, so the declarative stuff is pretty straightforward. It's just do this, do something. And the when we talk about functions, a single line of text might actually involve like doing a gajillion things. So if, for example, I had like some um, well, okay, let's take an example. Let's say that I want to compute the area of a triangle. Okay, perfectly good mathematical kind of question or thing that you might want to do. Hey, what's up?
Lights are on inside your car.
Oh, really?
Yeah.
That's weird. Inside, but not outside. Dome light?
Yeah.
Can you go problem solve?
Sure.
Okay, thanks. That's weird. Um, okay. Yeah. What a mensch. You guys know that word? No. So it's German, but in that case, I'm using it in its Yiddish usage. So Mensch just means man. Um, So, like for example, Nietzsche talks about the das or the Übermensch. Yeah. Um, but in Yiddish, Mensch has the sense of like he's a real upstanding kind of guy, like he's a mensch. Yeah. So anyway, okay. So where what was I saying? Let's say we wanted to like find the area of a triangle or something. Okay. There might be multiple steps involved in actually doing that, but I could write a function that's called like area of triangle, and a single line would really represent this 12 lines of code over there, right? So yeah, we'll look at that when we get to functions. But yeah, okay. So the declarative stuff is not all that particularly interesting. It's just do things. Um, and whatever those things are, well, it depends on what you're trying to do. Yes, it is. Yes. So that print, like it looks like I'm typing a single line here, and I am, right? But somewhere within Python's interpreter, print really does a whole bunch of stuff. A lot of that is hidden from us, and stuff just magically appears on the screen. But it really is a quite complicated set of things. Yeah. Okay. So the declarative stuff, not all that interesting. Um, but then we want to talk about the conditionals and the iterative stuff. And I'll do conditionals first because they need to go first. Uh-huh. Let me guess, Thomas. Mm, mm. Yeah, it's a little hard when there's only one door in the room, right? Kids these days. Okay, so these are going to be things that are of the form if or if then or if then else. Okay, so in order to do that, I first have to have okay, a Boolean expression, something that's going to evaluate to true or false. Okay, and that's the thing that's going to decide whether or not the conditional gets executed or not. Okay, so for example, we could have something like if x is greater than 3, something like this. Okay, so inside the parentheses there is my Boolean expression. X is greater than 3. So that's a mathematical statement, but it's a Boolean in this case because X is some variable with some value, and it either is or is not greater than 3. Okay, so that's the true or false part of the question. Okay, now the other thing that I have to do, and this is sort of a particular to Python, is so let me actually type one other thing. What was the issue? The okay. I owe you a drink, man. I owe you many drinks. Yeah. Um, makes sense. Okay, so Python tries to organize code in a very readable way. Okay, so in this case, I've got two print statements. X is greater than 3, and I like sandwiches. Okay, and what will happen assuming X is greater than 3, which it is because I defined it to be 5. Okay, so what should happen if X is greater than 3? Both things are going to print. Okay, but let's say that I change X to be 2. Um, okay, then what's going to print? Only the statement I like sandwiches. Okay, now how do I know that that's going to happen just looking at the code? It's not indented, or the X the X printing is indented. Okay, so the things that would be executed if the condition is true are indented one tab over from the if condition. Okay, and that's how you know what's inside the condition versus outside. Is purely based on indenting. Now, the reason that Python does it this way is, um, let me go over actually to a different um, program from my other class. Okay, so this is C code. Okay, and what C requires that you do is that you tell what's inside versus outside. By the inside has to be inside a pair of matching curly braces, a left curly brace and a right curly brace. And you see how I've tabbed over these two instructions? I didn't actually have to do that. It's not required, but it sure does make it easier to read, right? Okay, so basically C programmers, and C has been around for a while. It was kind of originated in the 1970s. Um, and it's not like it came out of nowhere. It was sort of built on and inspired by earlier languages. Uh, C programmers for, basically 20, 30 years have been doing this. They have to have the curly braces, but they tab over uh, to make it a little bit easier to read. Okay, so when the guy who created Python, uh, Guido von Rossum is his name, when he started doing that, he's like, well, everybody always tabs over anyway. So why do we still do the curly braces? Let's just get rid of that. But tradition, okay, yes. So I'm sorry. Exactly. The second you guys say that word, all I can hear in my head is like Fiddler on the Roof just goes nuts. Okay. Um, yeah, tradition. Yeah. I actually played that. So in high school, I think it was my freshman year, the theater group did Fiddler on the Roof. Well, fortunately for them, our high school had a string orchestra. Okay. And so, yeah, that was a weird score to play because it's very, the chord structures and stuff is not, what you would expect. Anyway, so, yes, tradition. So, right, so the tabbing is the only thing that actually matters, right? And there's no curly braces or anything. Now, I also have to have this colon right here, and right, but again, it looks technical here, but if you guys look at it, you could be like, oh, it's perfectly readable. Okay, so so basically, I mean, this is why Python is very popular, especially with beginning programmers. Is it reads kind of just like English, right? You don't have to really know a whole lot of programming to be able to read this. Whereas if I gave you guys, oops, this, right? You look at that and you're like, what the hell is going on, right? A good question, right? So the question is, assuming there's downsides to Python as well. Um, there are several. Okay, so Python is what is called an interpreted language. So really, so when I execute this, I'm telling the Python sort of interpreter to run this set of code. Um, that interpreter is actually not written in Python, it's written in C. Okay, so it's built on top of another language. Um, what that means is that it can be, you sometimes have a performance penalty. Okay, so it can be a little bit slower than, say, writing in C. Um, but it also, Python can allow you to get away with some bad programming habits. So, for example, when I declared x to be equal to 2, what data type is 2? Like, what kind of thing is that? It's an integer. Did I ever say it was an integer? No. And if I did something like, for example, I said, let's make this one 7.5, which has clearly got to be a floating point number because it's a decimal, right? Uh, and I tell it to add that, it just does it. But what I've done is I've added an int and a float, and those are two different data types, and that requires a data type conversion and a bunch of complicated stuff to actually make the machine do it. And did I tell any of that here? No, Python just did it, right? It's nice. Um, and so that's, I think, one of the downsides is that it doesn't make you really think about data types, and you can play fast and loose with them. And in fact, you can change the data type of an object sort of on the fly. That's a bad habit, not in and of Python, but it's a bad habit in other languages like C, where you can't just do that, right? You got to be much more careful. So yeah, it can develop. It, I mean, it's not like Python is automatically going to do this, right? But if you were sloppy with Python, you can get away with things that you can't be sloppy with in other languages. Um, yeah. So, but it really is a nice language. And of course, anything that's named after Monty Python is uh, is good. Which I don't know if I mentioned that, but yeah, that's why it's called Python. It's yeah, and so in a lot of the example or like documentation you'll find, then they'll use like spam and eggs and other Monty Python kind of references as variables or examples, right? Yes. Well, that one's a little hard to type out, but yes. Um, yes. Okay. So the conditional stuff here, um, I also can do something like this. Okay. And when I make an if else construction, precisely one of the two things will get executed, right? Because either the condition is true or it's not. Yeah. If this is not true, yeah. Um, well, okay. So there's two ways to think about that. One would be, what's the opposite of being greater than 3? Less than or equal, right? So you could just flip the inequality. But there is also a not operator. So I could, for example, do something like let's say I had some really complicated Boolean expression and I didn't want to actually think through the logic, right? I can negate it like that. Okay. Um, yeah, so I can put not in front, and in fact, I can do other Booleans, so I'll do that in a second. But yeah, if you have some really complicated expression, you can negate it just with the basically the word not. Okay. So if in an if else construction, precisely one of the two things is going to happen because the condition is either true or it isn't, right? There's no third option. Um, that's the axiom of Hamlet, right? To be or not to be. Yeah. Okay. So there is also, you can do what's called an else if, and this requires another condition. And I really should put this at the end. Okay, I'm not sure why it's giving me squigglies. Let's see. Oh, Yeah, that's why. Okay. This is different, and so let me put a comment in here. So I could have sort of a compound kind of thing where if it's greater than 3, print that. If it happens to be exactly equal to 2, print this, and otherwise print something else. Okay. Um, this can get you into trouble um, if you have too many of these things and it just becomes kind of a minefield of logic, but you can do it. And so, for example, there we do that. Oh, and I should have done, yes, okay. So then why did it print? Oh, because x actually equals 2, duh. Okay. Yes, so that actually brings us to another thing, and this differs from language to language, but most of them do it the same way that Python does, which is notice when I declared the value of x, how did I do that? I used a single equal sign. But when I was asking the question, is x actually equal to some number, I used a double equal sign. Okay. And in math, right, or in human writing, we don't have to worry about that. Okay. So you just use, like in math class, you use the equal sign in both meanings. And because you're all human and not morons, you guys just don't worry about it, right? So let x equal 7 versus if x is greater than 0, then right, like you don't think about that. You don't have to, but the computers are not. I mean, think of a computer as basically the world's fastest moron. Okay, it can do exactly what you tell it, and it can do that very, very, very quickly, but it cannot understand context. Um, it's this is not the way it works. Okay, so it will do exactly what you tell it. Now that may or may not be what you want, but it's exactly what you've told it. Okay, so anyway, uh, the double equals is a little bit annoying, but most languages are like that. And the reason is because we're using, you know, we're defining the value of something versus checking whether or not it's equal to something else, right? Those are two different kind of operations. Okay, so got that, and um, so that's basically all the conditional stuff, right? Is um, if, else if then else, or if else, right? And I could have as many of these elifs as I want, but like I said, you should be careful with that because it kind of, um, if you've got some really complicated expression, it can kind of turn into a minefield. I can also do compound Boolean expressions. So for example, I could ask, is x greater than 3 and y less than 7? And I'm just making something up here. Okay, and who cares what I'm printing at this point, right? Um, so waffles did not print, and why didn't it print? Well, what were our values of x and y? 2 and 7.5. Well, neither of these two statements are true, so the and of them is not true. Okay, so you can do and or not, right? All the kind of Boolean expressions that we've seen before. You can do any combination of those that you want. I found that it's good practice to with Python to maybe slightly overuse parentheses just to kind of be careful. Um, it saves you from headaches later. But yeah, uh, right. So you can build compound expressions if you need to. Okay. So questions on the compound, I mean, on the conditional stuff, and then we'll talk iterative stuff. Okay. All right. So iterative expressions. Um, there are three kinds in general: while, do while, and for. For is actually a special case of the while loop. Okay, so to explain the difference between the while and the do while, it's actually a little bit hard because Python doesn't have the do while construction. C does, but Python doesn't. So let me just start with the while, and then I'll explain how the do while is different. So I could do something. So what was our value of x? 2. Just for sake of demonstration, let me change that to 5. Whatever. So I can say while some condition is true, for example, that x is positive, I could print x. Okay? What would happen if I executed this as is? Yeah, it's going to print forever. And why is that going to happen? Because, yeah, because I never actually changed the value of x, right? So I'm printing 5, and then is 5 greater than 0?
Yes.
Yes, so I print 5, and then just it loops back over and over again. Okay, so what I would want to do here is subtract 1 or in some other way modify the value of x. Okay? And there, it only prints a specific number of times, in this case 5. Yeah.
Couldn't you write this as x equals x minus minus?
No, you would want to do, that's bad notation. You would just do this.
Okay.
Yeah. But that's not actually valid in Python. So in C it is. You could also do minus equals 1. I don't particularly care for that notation because I think it's hard to read. I prefer to just be a bit more explicit and write x equals x minus 1. Okay. Yeah. So the minus minus and the plus plus operators are valid in C and C++ and Java and stuff, but not in Python. Yeah. Okay. So in this case, did we know in advance, or is there anything about the 3 lines of code that I've written that tell me that it's going to print 5 times? The only way I know that is because I happen to know the value of x. It happened to be 5, right? And so it printed 5 times. Now, what's happening is the condition first gets checked. So what's the initial value of x? 5. Okay. Is 5 greater than 0?
Yes.
So execute the loop body. So print 5, and now x is going to be redefined to be its old value minus 1. So now what is x? 4. Then you come back and reevaluate the Boolean expression. Is 4 greater than 0?
Yes.
So we print, and now x is 3. Is 3 greater than 0? And so on. Okay. So there's nothing in those 3 lines of code that told us it was going to print exactly 5 times because it depended on the value of x. Okay. And we happen to know the value of x because we picked it, but theoretically you might not actually know that, right? So this would be the example of, like, let's say that I bring in just like a pallet of bread and peanut butter and jelly, and I just say, start making sandwiches, boys. You guys don't know how many sandwiches you're going to end up making, but you know that you'll keep making sandwiches until you're out of stuff. Yeah. Okay. So right. So with the while loop, you have to have some sort of Boolean expression. In this case, we were just checking if x was positive. And then obviously you need to do something so that you don't end up in an endless loop, because that's usually a bad thing. I say usually because there are instances where you do have endless loops. Basically, any of your video games, right, you have to explicitly quit them for the game to stop. Otherwise, it just keeps running. Yeah.
You have compound for well loops?
For the condition,
X is greater than 0 and
yes,
y is greater than 0?
yes. However, uh, so we can have compound conditions here the same way that we did up there. Um, you just would want to be careful in doing so that you don't get yourself into a logic puzzle. Okay. Um, and in the case of something like the sandwiches, right? While you have bread is greater than 0 and peanut butter is greater than 0 and jelly is greater than 0, right?
And each time you subtract 1 from all 3 of those.
Well, or 2 from the bread, right? Because a sandwich has 2 pieces usually. Um, and some quantity of jelly. Let's say that jelly comes in like, I don't know, let's say I gave you a pallet of like single serving, like those little packets of jelly like you get at McDonald's or something. Um, and do they bake peanut butter in those little single serving things? It seemed like it would be a little difficult. Huh? What? Oh, like a little cup kind of thing, like a salad dressing type thing. Yeah, okay. So let's just pretend that peanut butter and jelly come in discrete quantities like that so that you can actually count the number of jellies or peanut butters that you have. I mean, this is a contrived example, obviously, but yeah. So yeah, you could do compound expressions there, but do so carefully. Okay. All right. So the while loop is that. The difference between what's called a do while loop and a while loop is when the condition gets checked. In a while loop, you check the condition before you do anything. In a do while loop, you do the body of the loop and then you check the condition. So it's a matter of when do you check, before you start or after you finish. Okay. It's a little hard to demonstrate with Python because Python doesn't have the do while loop. I mean, I could make one, but yeah.
You could do well, true, and then at the end, if not
Right.
condition correct.
Yeah. So you can do that, and that it would look like this. So doing the following makes my while true print x, and then I could say x equals, well, okay, one other thing I need to do is I need to reinitialize x to 5. And I could say if x is less than or equal to 0, break. Okay, so I could do that, and then, oh, sorry, it's capital. Okay, so that would be how I would basically make a do while loop. But as you can see, it's a little bit kind of contrived. Yeah, so I can get that functionality if I wanted, but it's not sort of built in as a default way of doing things in Python. Okay, so yeah, so the idea here is that the condition gets checked at the end of the loop rather than at the beginning. Right. Okay, and then there's a special case of the while loop that in a sense we've kind of used because here we printed a specific number of times, 5 times. So I could also do, and this part's going to drive you guys nuts. Okay, for I in range 1 to 6, print I. So this is why it drives me crazy. 1 is in the range, 6 isn't. Okay, so in math notation, this would be like, right, something like that. Okay, which again I find extremely irritating. And if I ever am in a room alone with Guido von Rossum, um, let's just say two programmers enter, one programmer leaves. Okay. Um, Yeah. So that will cause a number of errors. Now, I think the reason why he did that is because often in programming we actually start counting at zero instead of one, and 0 to 5, I print 0, 1, 2, 3, and 4. That's a total of 5 things. Okay, I think that's why he did it that way, but I'm not for certain. Um, yeah, this is one of those things that just remember. Okay, that the second number is not included. Okay, so if I do that, and in fact, let me just, for sake of demonstration here, change it to 10. Um, Nothing special about the numbers. Okay, so it prints, in this case, 0 through 9, and then stops. Okay. Um, so did I ever tell it? So I starts with what value? 0. And then I printed 0. And then I got updated to be a new value. Well, what new value? 1. And then 2, and so on. How else would you count? But did I ever actually specify that I was adding 1 each time? In Python, if you don't specify, it's assumed to be just adding 1 each time. Could I program, or could I make this count up by 2's each time? Yes, exactly. And in Python, it's easy to do that. I add right here a comma and a 2. And that would tell it to count up by 2's instead of counting up by 1's. Okay. And obviously, you could count up by any number that you so chose, just whether or not it's useful is another matter. Yeah.
Could you also replace the 10 with 5 and then print 2 times I?
Yes. That would end up printing the exact same things, right? Because if I is a number, what's 2 times I? So if I is an integer, 2 times I is always an even number. Okay. So the difference would be like, why would you do one versus the other? Well, let's suppose that you had a list of numbers and you just wanted to go every other one specifically for some reason, then you would want to do it like this. Okay. What Thomas suggested would accomplish the same printing, but if you were already working with something where you had 10 things, then if you've already got 10 things, but you wanted to skip over them, for example. So maybe a good example of this would be like, you guys know in a lot of memes, it started out with the SpongeBob meme of where he's like a chicken or whatever, and he's got like a beak and he's like doing this number thing, right? And how does the text appear in those memes? Yeah, it's alternating capital and lowercase, right? And then, of course, that's gotten used in lots of contexts that have nothing to do with SpongeBob, where there's that sort of alternating capital and lowercase to make something look ridiculous. This would be an ideal instance where you might want to do something like that. Yeah.
Sometimes that the capital and lowercase is used to represent sarcasm.
Right. And that's which is where it comes from, the meme, right? Where like people are making political statements on Twitter or whatever, and they're like, "But how are we going to pay for that?" Right? And they do it with the alternating upper and lower case to kind of um, just be kind of ironic or sarcastic. So yes, um, uh, right, okay. So yeah, so you do have the option to do. Um, um, do that. Okay. And that's basically the iterative stuff, right? So uh, we can think of, really, there's in Python 2 things, but in C there's 3. So in C, I wouldn't have to be quite so contrived about this. I could just say, do this while x is greater than 0. Okay. I mean, it would look slightly different, but um, because it's C, not Python. But yeah, so in Python, to do that, I'd have to kind of contrive it like that. So the moral of the story, I guess, is the for loop is this kind of thing, and the while loop is that kind of thing. Okay. So, question, preguntas, fragen. Right. Okay, so it's not rocket science, really. It's just you're doing something either until a condition is no longer true or for some specific number of times. Um, and in fact, that specific number of times can be sort of semi-specific. So, for example, what was y? 7.5. Let me just define it to be 7. Just chop off the 0.5. I could do something like this, right? Where how many times is that going to run? And in fact, let me get rid of the two part just for demonstration here. Well, it depends on what y's value is. Now, do we know y's value? Yes, it was 7, so this would print how many things? 7 of them, 0 through 6. Okay, but let's say that in the course of the program, the value of y is changing. We don't necessarily know what it is while the program's running. I mean, we could like think about it and figure it out. Okay, but it you don't like if I just showed you this snippet of code and that's it, and said how many times is this going to run, you would have to say, well, it's going to run y times, assuming, of course, that y is positive. And exactly what that is, well, it depends on what y is. Okay. Right. So for example, where this could be useful would be like, again, let's say that we had a string of text, which is a phrase like, how are you going to pay for that? Right. And then I wanted to write a function that would go through and every other letter convert it to capital, or and every other letter convert it to lowercase. Then do I know how many letters are in my message beforehand? No. And so what I would do is I would say, instead of the number y, I would say it'd be the number of letters in my message, whatever that is, right? Yeah. Okay. Right. And then you'd have to do, -1 or whatever, just to make sure that you hit the end of the range correctly. But yeah. Okay. So on Monday, I guess we'll start talking about functions, and then of course that'll lead us into recursion, which is fun. Yeah. So, all right. Have a fantastic weekend, and if your group has not yet scheduled your meeting, please do so ASAP, so I don't have to send my goon army after you. Okay.